Hello and welcome back. My name is Corey, and you're my rubber ducks for the evening. And this is a series of episodes where we are creating a programming language from scratch using the C++ language. And Vim is our editor. We're working on a terminal window using fundamental tools such as Flex, Bison, Google Test, ICU, and modernish C++. I say modernish because we use modern features where appropriate, to my knowledge. And we are on, what episode was that? I'll forget by the end. Episode 93. And we are continuing our push to improve our performance using a technique that we've been focusing on, where we've been creating opcodes where instead of always reading from the stack, rather being able to take an index from an index into the stack, so as opposed to requiring everything to be put on top of the stack first. That's what we're going to continue doing. And let's see, what do we normally do? On the right hand side, I will have our make clean, so that we're starting with a clean compile, make test watch, and that will get going. On the left hand side, we will show that if we say git log, our last commit was the end of the previous episode, episode 92, and status, no files have been changed. The call grind is just it's an old performance file that I'm wanting to keep around for just a little while. But as I've said on multiple episodes, nothing up my sleeves. I don't have anything pre-prepared. This is watching development as it really happens. I don't know how I'm going to solve the problems I'm intending to solve. I've thought about them, but I don't know how it's going to turn out. So you're going to see all of my mistakes, good and bad, in this. And where I wanted to go, let's see, I pulled up the documentation for our opcodes. All the opcodes that exist now. And there's quite a few. But the one I think I want to tackle today is maybe return. Return may not be that big of a deal, but print. Oh, I think that's going to be called a lot, and that's going to give us, that's going to be good to do. And let's see. Yeah. Okay. Our tests, I don't think that we're going to get a, if I say make tests, it's just going to run them all again. We're running around 4 milliseconds. And I think we're at the kind of bumping up against 5 milliseconds, but well, let's just see where this puts us. So I'm going to edit on the left-hand side. I'm about to open up, let's see, what all files do we want? We definitely want our include opcode, our source opcode, our source program, which one? Almost all of these. Analyze, source program, dump, source program, execute. And if we're doing the print, because print is not a function call, it is a construct. So that means we've got a source AST node print. And I think I want to open source AST node unary, maybe? Yeah. All right. So we're going to go down to the bottom because print is at the bottom. And we know that we're going to want an S version and an I version. Let's well, I want to change that to call func S. We'll get to that in a moment. For right now, print s, print I, and now it's going to complain because not everything is defined. That's all right. Print and s, I, and so print s is still just 1, but for this one, it's going to be PC plus equals 2, not just 1. All right. How about this? Dump binary I. We can do that. And now that's our S version, and our I version for the index version is dump binary underscore I. Okay. Just using our macros to make life easier. And now what are we in? The execute. Okay. So, did we have something for expression already that used the word expression? Nope, just print. Either way, we've got to get the expression. Okay, so we've got cast op, in which case we'll get operand, and cast op I. And that's really what we need. We could just use the word operand instead of. And you know what? Is unary? That's all right. I'll just do this, and instead of cast, we'll say print op, and all right. And now go to the end. And this will now be, nope, print op. And that will give us expression without popping. And then now we just try to convert it to a string. Do we want to, so for these, for binary op, that just, oh yeah, we've got to do the, how many, plus plus versus plus equals 2. Okay. We don't need to do the plus plus there. s print I. Whoops. So print op s, print I, we call print op I. Oh, this is the same. We try to cast it, we try to convert it to a string. And we saw the AST node print, that's an issue. Well, we don't know if any of the rest of this is compiling because we haven't gotten there yet. But this is AST node print. And here is all right. So we're going to say instead of the index is, that's fine, but instead of operand, I'm having to delete all of these. Definitely don't need to return there. All right, and now let's do this as a :%s. So change out the word operand for expression. There we go. Only 3 lines, but that's all right. So I've got an index that's -1 by default. If the expression is an identifier, then try to figure out where it is. If we now have an index, then instead of op I, it will be print I and the index. Else, we'll just compile the program, and this will be print s. Are there multiple types of print? Oh, the type. Wait, do we not use that anymore? Yeah, do we not use this anymore? Can we get rid of it? Well, for right now, we're about to find out. Line 31. Oh, AST node identifier is not in here. Okay. And before I hit save, I'm going to go on the right-hand side and edit the make file and all right, that's added. Now go back to our compile and there, write the change, see if everything compiles. If it does, that's a good thing. That's nice. It usually doesn't, though. It usually gives me an error or a test will fail or something. Let's see. No, it's all running. Okay. Let's see what our changes are. Make file, opcodes. Oh, I think I was thinking that originally we might have to say what kind of printing it is, HTML escaped or something like that. But now that goes with the string, so I think that's why we don't need that anymore. Okay, well, I'll think about it. It might be able to go away. Opcodes. Here we are in the execute. That all looks correct. All right, now episode 92 is the last one. So I'm just doing this so that it will rebuild what it needs to rebuild. And actually, really quick build, but it's still all the optimizations. So this is the state of it before we did our current print optimization. All right, and I want to time build apps tests gtest brief is equal to 1. Okay, wow, that's pretty fast. Yeah, we're in the millisecond range anyway. You say it's saying 4 milliseconds. Why does this say 7 and 6? Setup and teardown. So I doubt we'll get much better reporting of speeds. I know it's stopped. It's to think. I go back to the master branch. Now all of our changes that we just put in are there. It's going to rebuild what it needs to. And in the meantime, I want to look at the test file. And now if I time these, yeah, it's all... What's funny is it's consistently that, whereas before... Sometimes it hit 9. So, okay, maybe we got a speed boost, which I'm pretty sure we did, but could all be in my head. So what can we do? We can edit source program execute, go down to the bottom, and just say cout 1. There, put it there. And this can be cout 2. Just recompile this. Forgot. Shouldn't have done. I should have done the test watch. I'll just do that in a moment. Okay, we see a bunch of 1s and 2s. 2s are the optimized. All right. And what I want to see is when we say print, okay, all these would make sense that they're 1s because it's having to call, ooh, but you know the index could use that speed up as well. We keep going, but look, this is a, well, no, it's not a, it is a string literal, but then there's an index, so oh, we're not taking that into account, and we should. The that. So far we've only been looking for identifiers, but what if it's a string literal? Because string literals are processed specially. They are put, they have an opcode and they are put onto the stack. We could reference that. Okay, that's a good thing to know. But yeah, like this print A, these are obviously, those are being optimized. In fact, we can check that by just saying cout there. That way we can see it. How about we just say this? I forget that we are in the program object. So we see, oh no, don't bytecode, I meant this code. That's what I meant for it to be. So it's only printing out the places where it optimized. Print A, yeah, all these print A, print B, print A. Obviously the dot length is not being optimized, but print end time, so it print str. Okay, that's nice. Okay. Remove the cout one. Now, what about those strings? So when we say print some string, let's use that vim command from earlier to get to the AST node print. Number 6. Else, can I do that? I can't do that. It's got to be dump. See what's not getting optimized away over and over again. A subtract, a period, function calls, but look, string. Okay, so now I want to edit source AST node string. When I hit the shift with my left pinky to hit the capital S, with my right pinky to hit the capital S with my left hand, sometimes it moves up and hits the enter key, and that's what happened there. Anyway, all right. The preprocess does that. Compile literal does that. The compile looks for the string using the val and type. That's what we need. Okay, so on the left hand side, we're going to need to do this anyway. What was it called? Print. And this, now we need AST node string, because we're about to add that. So string is, whoops, I meant to do. So this needs to be before this one here. So we can just take it up to the top. AST node identifier, AST node string, because yeah, they're commonly used. All right. Put us back on that. And now so we'll be going back and forth between 6 and 9. So 6. Else, oh, and I need AST node string. All right. String. String of that. Why? Because I need more than one thing. So, ooh, where is my help file? AST node string. Can I get to its, oh, well, yeah, give me the class. There we go. Compile literal, location, and private are val and type. I need those. So I need to get val and get type. That's the safest way. So, okay. So, edit, include AST node string. And its at return is going to be the string value that this AST node represents. And it's going to be a standard string. Okay. And then get the type of string that this AST node represents. And I don't know what this should look like. And this will be a const that ampersand called get type const. Okay. It's probably going to complain because they're not defined, but we're about to do that. Edit the source for AST node string at the very bottom. We're just going to go that. Okay. And now this, let's see. All right, let's see if that works. It should. All right. Now, the print. There we go. So, the string is equal to string convert dot get. What would I call it? Get string. It should have been get val. Now go back to number 6. Get val. Type is equal to we don't have a name. All right, so B9 here, where we compile, this is what we want. We want going to 6. Okay. Missed one. There we go. All right. So now strings is program get strings. That's fine. If strings.count there, val and type, then print I, and where? Val and type. Yeah. Else, we do the normal thing. Nope, I don't even have to do that. Forget all that. I just have to say index is equal to there. And then it will say, and now if there is an index value, then do the correct thing. See if all this compiles now. Okay. Left-hand side. Which one are we going to? We're going to execute, which is 5, and there. So print S, that's fine, but what I want is this print I. When I'm there, let's do cout, because this is cout this code, just because I want to see what it is. So this will give a list of every time it was able to use the print I, it'll print out the code from that program. Oh, it was able to, well, these are the templates then. And that makes sense because this is, yeah, the hello and world and stuff like that. Okay, that's fine. So this is working correctly still. These prints all made use of it. So there are, yeah, this was a non-trivial add. That's good. This one right here. Okay. I think I'm very, very happy about this. Even the print nothing. And look, these print chars and print, yep, that's gonna do it. Okay. And in fact, well, now that we know that, okay, I want to go back to the test and look for that char example. This one right here. Let's just do cout p1.dump bytecode. Oh, here it is. So yeah, print I of 2, which is going to be, that's char, because A is going to be 0, char is 1? Oh, sorry, I was looking at the wrong one. A is 0, 1, why do we have 3? Oh, is 1 the iterator? Yes, I forgot about that. Okay, that's fine. Jump to 19. 19 says iterator next. Save that result into char. Is iterator end? Yes or no? Jump true with a pop to 36. Yep. Okay. That should be fine. Let's undo that. All right, so the difference is we added a dependency for AST node string. That's fine. AST node string. The question is do we need to duplicate this? So makefile include source and add those layers right next to one another. SI optimization for strings with print. All right. So where could we make use of this next? So, well, unary is right there. Let's look at that. Unary is doing this, and we stop looking for here's the string one. Now we need to say what AST node string is, and we have to add it to the make file for unary. And this should work. It does. So this is the unary. I need it with binary as well. So it would make sense on the function call to have it. The cast, the binary, function call. Print already had it. The ranged for. Oh, we haven't done it for the ranged for or for the if statements or anything like that. Okay. Unary has it. These are the computed expressions. Okay, so let's go back and let's add it to node while, because we'll need it. We'll need identifier for that as well. While and if, even if we're not. Period, we'll need it. Index. Where's index? Oh, if else, that's going to need it. Does map need it? It could. No. No, no, no. It won't. But I already said period slice. And return will need it. Are there any others? While has it. So I think because of that, identifier needs to go before array, and in fact, string does too. Assign, oh, assign needs it, definitely. Are there any more? That's the only assigns. Okay. The for is going to need it. Okay, let's just see if I messed up my make file. Not too much. So now if I edit AST, wait, first, no, I don't meant to do that. Get status, get diff, Wait, no. I'll go ahead and look at this. Yeah, all of these in the make file. I'll go ahead and add those. And then in the unary, you got the string and that. Okay. And that was in where? Unary. Okay. For upcoming SI string support changes. Okay, that's fine. Now, what I need to do, I may need tests, so I'll go ahead and open that. Source AST node. Well, first, program execute just in case. Source AST node unary is the one that I just did it with, right? So source AST node binary. Oh, and I haven't done the ternary either. That's all right. Okay. AST node string. Now, there we go. We gotta else if type ID of LHS. There we go. LHS. LHS index is that. There we go. And now instead of LHS, we're going to go with RHS and RHS. All of our tests should still pass. And they don't. Oh, because this should be RHS. Yeah, good. So that creates, okay, that one saves that. And what else? So we added it. Wait, that's not all the binaries. Because the logical ones could be as well. And I think for this one we only need uh-oh. Nope, that's fine. So if it's an identifier, else if it is a string, either way it figures out the right LHS index, and then again, everything should pass. Everything's passing so far. All right, if we edit the source AST node, let's do the function call. No, for the function call, it has to... Yeah, the function call can't benefit from this, because we have to push it onto the stack. That's the way a function call works. Okay. AST node array. Do I want to do an assignment? We did the binary. How about a cast? Let's do the cast. Okay. This is going to be expression. Okay, so now the cast should work. Everything's still working. Okay. Do while... no, not float. Don't want to do the for yet. Function call, function declaration, identifier, if else, index, the integer, library, map, period. We haven't done the period one. Do we have enough time? We're already at an hour. I want to make sure that we've gotten everything converted over. So print, yeah, we did that one. Ranged for, return, slice, string, ternary, unary. Did we do the unary? Yes, we did. Use, while, and that's it. Okay. And what did I say about the function call? It can't use these. edit function call. It's using identifier and function call. Okay. So it was still using identifier. Okay. Check our diff, and so we fixed the makefile thing. In our node binary, we support it. In our node cast, we support it. And in our node unary. Unary, binary, and cast statements. Okay. Add SI optimization for strings with, so add SI optimizations for strings with unary, binary, and what was the last one? I don't remember. I have to go to the other one. Cast. AST nodes. All right. With that being said, I think we're at a good place. What do I want to do? Make clean. Update our documentation while we're compiling. And I just want to kind of test our timing. I don't think it's going to improve the Fibonacci because, well, yeah. Still bouncing back and forth between 4 and 5. All right. Tang-s and feed in fib.tang. And we're still below 0.7 seconds. So, I mean, that's fine. We didn't, we're not getting, it's not taking longer. All right. So I think what changed? Oh, a lot of stuff. Yep. Episode last one was 92, so this is 93. Okay. For episode 93, push all of that up. All right, tag has been pushed. And then one of the last things we usually do is check the lines of code. 12.5. All right, we can do that. We can deal with that. And yeah, so that gets us to a good stopping point. And so where are we going next? Well, we've got obviously other opcodes to improve. And again, it is kind of rolling around in the back of my mind. We need to improve the efficiency of the garbage collected values. Get rid of that mutex. Yeah, we've got to do it, and there's a couple different things we can do, but to just test, is it a viable path? How much refactoring do we want to do? It's going to be some work either way, but yeah, well, we'll. Favorite saying, we'll burn that bridge when we get to it. Has an official name, Mal something, I don't remember. But anyway, yeah, where you mix up your metaphors. Having said all of that, we're at a good stopping point. Thank you for joining me tonight, and we'll come back and we'll continue with this and continue making improvements to our language. Thank you. Bye.